Today we're going to look at parallel and perpendicular lines, and the learning goals for today's lesson are we're going to be able to determine the equation of a line that is parallel or perpendicular to another line. So perpendicular and parallel lines, two parallel lines are going to have the same gradient. The reason for this is because if they're parallel, they'll never meet. They are moving in exactly the same direction. That means for the exact same change in their x value, they're going to see the exact same change in their y value. So their gradients are going to be identical. Parallel lines, identical gradients. For lines that are perpendicular, they're going to be, obviously if it's a positive gradient, a perpendicular line at 90 degrees is going to have a negative gradient. So the relationship between the actual positive the gradient of the first line and the second line, they're going to be negative of each other. So the gradient of the second line is going to be negative of the gradient of the first line. As well, because what we're doing is if we've got two perpendicular lines, they're going to be always at right angles to each other. The steepness of the first line is going to mean if I've got a very steep first line, the second line is not going to be very steep at all. So if my first line is very gentle, then the second line is much more steep. This means that the relationship between the actual size of these gradients, regardless of how positive or negative are, the size of them, they're going to be an inverse relationship. As one gets much bigger, the other one gets very small. And so that's the relationship that we have. So there is this formula. And that's the reason for this formula. They're satisfying this relationship that the gradient of the second line is going to be equal to the negative inverse of the first gradient, the negative inverse of the first gradient. So all we need to remember is this formula here for perpendicular lines, that the gradient of the second line is going to be equal to the negative inverse of the gradient of the first line. So to find the equation of a perpendicular or parallel line, first thing we need to do is find that gradient. So if it's parallel, the gradients are the same. If it's perpendicular, it conforms to this rule here. Then we need to substitute a known point into y equals mx plus c to determine c. So we can see on our graph here that we've got some parallel and perpendicular lines. So just having a look at each of these lines, the two that are parallel are these two here, the green and the purple line. They're parallel, so they have the same gradient. We can check that out. We can see that if I look at the gradient here of this one, the rise is going to be 2 and the run is 3, 2/3. We can see and check that out with our green line as well. They are the same there. So the gradient of our green and purple lines is a rise of 2 and a run of 3, 2/3. If we have a look at our blue line is perpendicular to both our green and purple lines. So if we have a look, they're 90 degrees to each other, 90 degrees to each other. So the gradient of our blue line, the gradient for it should be negative the inverse of the gradient for the first one. So it should be negative, and it should be 3/2, not 2/3. Let's have a look. Let's choose 2 points that are there any 2 points that are actually on the line? No, probably not. But we can try and see if we can get pretty much the right value. If we choose this point here, and then have a look, if it reduces our run should be 2, and our rise should be -3. So if we move over 2, we're about over here, and our rise here, -3. So we've dropped down by -3, and we've run along by 2. So we can see that our gradient here for this one, our gradient here for the line, the blue line, is -3/2. So we can see that it's the inverse and negative of the green and purple lines there. In order to determine the equations of any of these lines, we've got known points that we have that we've been given in each of the two or each of the lines. So then we can substitute our known gradients in with those points to get the equations of those lines. Let's have a look at our first example here. This example says find the equation of the line that is parallel to y equals negative 2x minus 7 and passes through the point 19. So firstly we need to determine the gradient. Because it's parallel, the gradients are the same. So that means that m1 is equal to m2, and that equals negative 2, because we've got our format here, y equals mx plus c. Y equals mx plus c. So that means that is our gradient, negative 2. The coefficient of x is our gradient. So because they're parallel, the gradient of our second line, or the line that we're trying to find, is negative 2. We also know that it passes through the point 19. So let's plug that into our y equals mx plus c equation. The y value is 9. The m value, negative 2. The x value is 1, and we're trying to find c. So that means we've got 9 is equal to negative 2 plus c. Add 2 to both sides, and we get that c is equal to 11. So then we can say, therefore, the line equation is y is equal to negative 2x plus 11. For our second example, we're asked to find the equation of a line that is perpendicular to y equals 3 over 4x minus 1 and passes through the point 3, negative 2. So we know it is the lines are perpendicular. So that means m2 is equal to negative of 1 over m1. That means it's the negative inverse of the gradient that we have. So m1 here, m1 is 3/4. We're given it there, 3/4. It's the gradient, it's in the form y equals mx plus c. So that means the inverse of that is going to be 4 over 3. So the gradient for m2 is negative 4 over 3. We know that y equals mx plus c. Our y value here is negative 2. Our gradient for our new line is negative 4 over 3. Our x value for our point that we know is 3. And we're trying to find c. So this is going to be negative 2 is equal to negative 4 plus c. That means if we add 4 to both sides, we get that c is equal to 2. So therefore, y is going to be equal to negative 4 over 3x plus 2. So learning goals, just to recap for today, we were looking at determining the equation of a parallel line and determining the equation of perpendicular lines.